In previous video, we derived these two equations. One is the pressure disturbance equation and another one is for velocity. We derived these two equations previously. Now we want to write these equations as a matrix form, and as you can see that I already have written these two equations in matrix form. Here P and U has been written with partial derivative with respect to t. This is the coefficient matrix, which is called A, and it is defined here. Then we have Q, and remember that in the book it is not recognizable to know whether Q is a vector or a scalar quantity. The book of Levesque, that book which we are following for these videos. So sometime I put Q vector just to make sure that this is a vector. Okay, so we have written the matrix form of these two equations. You must be wondering, in actual equation there is P tilde, U tilde and P tilde, and similarly in second equation we have U tilde and P tilde. But when we have written the matrix form, this matrix form, there is no tilde over here. The reason is when we reached at the result, then it doesn't matter to include the symbol tilde in the answer. These equations are for perturb problem. So I hope you got the idea. When we have u naught, which was initial speed, if it is not equal to 0, then we get this equation. But if u naught is equal to 0, then we can write a is equal to 0 k naught 1 over rho naught 0, so on. Now what we do, we want to find the eigenvalues and eigenvectors. The eigenvalues of this problem can be obtained by just putting a minus lambda I determinant is equal to 0. But before moving into the eigenvalues and eigenvectors, we must understand the reason why we are considering the eigenvalues and eigenvectors. So I actually erase this matrix, and we just need to focus when we have u naught is equal to 0, then A matrix is 0, k naught, 1 over rho naught, and 0. So this is the case for stationary gas. Stationary gas. As we saw that when we have scalar equation, this scalar equation has a solution q x minus u bar t. It depends whether the wave is moving towards right or it is moving towards left. Similarly, these are the acoustic equation, and the matrix form is here, and the coefficients are these. One coefficient matrix is given here. So it resembles with the advection equation. So its solution will also look like this. Q is equal to Q bar x minus st. Since we are dealing with acoustic equation, so in acoustic wave we have speed as a parameter. Here you can see that this s, which is just unknown, in future this will become a speed of sound. So s is a speed of sound initially. So the solution look like this, as I explained earlier why we have solution like this. Our problem is this matrix form solution can become partial q by partial t plus a partial q by partial x is equal to 0. If this is a solution, then it should satisfy this equation as well. Now, I emphasize again, this q is a vector quantity. Q is a column vector, right? But I did not put the vector sign in this equation. So let us assume xi is equal to x minus st. So we take a derivative partial q by chain rule. We need partial q by partial t first. So we have partial q by partial t, that will be equal to partial q by partial xi and partial xi by partial t. We get partial q by partial xi, and partial xi by partial t will be equal to minus s. Remember that this is a vector quantity. Okay. Now, similarly, we see that partial q by partial x will be equal to partial q by partial xi and partial xi by partial x. When we put these two expressions into this equation, we get minus xi partial q by partial xi plus a partial q by partial xi is equal to 0. We put it the value of partial q by partial x over here. We solve that equation. Minus xi partial q by partial xi minus a partial q by partial xi. I'm sorry, there should not be any xi. It looks like xi, but it is s. I'm sorry for that. So we just cancel minus sign, and you can see that this is a famous linear algebraic form. Here S is a scalar, A is a matrix, partial q by partial xi is a vector, and same is the true for on the right hand side. So this is equal to ax is equal to lambda x from the linear algebra. The x is actually partial q by partial xi. On the left hand side, we have a scalar quantity, and on the right hand side, we have a matrix. And we will talk about the eigenvalues and eigenvectors in the next video. Thank you for watching.